Hi everyone, in this video I will show you how to calculate the significant duration of an earthquake acceleration time history. The significant duration of D575 and D595. So in this spreadsheet here, so first in this video I will show you how to do that manually. Then I will show you how to do it using Deep Soil and Seismosignal software. So first I will start with manual calculations. So in this spreadsheet I have time, acceleration, velocity, displacement time history, and I also have the area's intensity in units of meter per second. So first of all, we need to calculate the area's intensity as a percentage. To do that, we need first to find the maximum value of the area's intensity of the motion that I have. So in this equation here, this function, I'm using maximum value for the entire range of column E. After that, I'm gonna take this value divided by the max, multiply with 100. Don't forget to fix F3. Then, so the function is gonna take this value, then divide by max always, and then multiply with 100. This is how we calculate the percentage of area's intensity or energy. Okay. Then I will find the time at area's intensity equal to 5%. So this area's intensity now in terms of percentage, the units of area's intensity here is percentage. So I need to go to 5% and find at what time I got 5% of area's intensity. So my goal is to find the time. Of course, I can use XLOOKUP function, and so the value that I'm looking for is 5 in this array, the red one in column G. The return value is going to be the time. So here is the time at 5% at 5% of area's intensity. And I skip the not found, and I add for match value, I add 1 because this is approximate. If I couldn't find exact 5, this is gonna go to the next value and take the next higher value of 5, which is 5.00 something. So I got at the time at area's intensity equal to 5%, I got 16.87. Then I did the same thing here, but instead of 5%, I took 75% of area's intensity, and I calculate the time that correspond to 75% of area's intensity. I obtained 24 point almost 5 seconds. Then I do the same thing again with 95. So I repeat this XLOOKUP function 3 times. One for 5%, another one for 75%, and then last one 95% of area's intensity. Okay, and that's it. So D575 is going to be equal to the time at area's intensity equal to 75 minus the time at area's intensity equal to 5%. So this minus this, I got 7.2. So this is the significant duration D575 seconds equal to 7.6. I do the same thing with D595. So in this case, it's going to be the time at area's intensity equal to 95% minus the time at area's intensity equal to 5%. I obtained the significant duration D595 equal to 22.5 seconds. Okay, so this is the manual calculation. Now let's move to another way to calculate this significant duration using Deep Soil. In this example here, I entered or I defined the motion in the motion tab in Deep Soil, and I have acceleration, velocity, displacement, area's intensity. Okay, so the units here doesn't matter because I always deal with percentage. So I go to motion metric and tools here down at the bottom. I open it, then I go to process, I click on process, then I go to single motion view, I click on single motion view, I will have this window. I activate this option, which is show the significant duration. When I activate it, it's automatically highlight the significant duration, but be careful. Deep Soil calculate the significant duration as D595. It does not calculate the D575. Okay, so what this number see here, what is this number is represent the D595. Let's compare this number to our value. So I cannot open that Excel file until I close this window. So here we obtained 22.5 equal to D595. Let's go back to our uh, manual calculation. 22.5, exactly the same number, you see. So deep soil cannot or doesn't calculate the D575. It just calculate the significant duration of D595. So this number here, what we see here is D595, which comes from the time at axial at areas intensity of 5 and time at the areas intensity of 95%. So this number minus this number, we obtained the D595, and we just checked, and this is equal exactly our calculation in the manual sheet, in the manual calculation in the Excel sheet. It gives you also another parameters. This might be useful to someone, to somebody. So the BGA, which is the peak ground acceleration of this motion, the maximum absolute value of the acceleration time history, and also the BGV, which is the peak ground velocity, which is the maximum absolute value of the velocity from this plot. So you can also calculate these value in Excel by taking maximum absolute, use max function and absolute to get the BGA and the BGV, and BGD, which is the peak ground displacement. Same thing, maximum absolute in Excel. You can obtain the same thing. So this is using Deep Soil. Now let's go to another software, because in Deep Soil we just obtained one parameter, which is D595. How about D575? So sorry, yeah, we obtained in Deep Soil, we obtained D595. We still need D575. So we can use another software here, which is called Seismosignal. This Seismosignal is one software from Seismo, from a company. It's called Seismo. I forgot the other term of the company, just Italian company. They have a full package of motion, earthquake motion processing. So this is just one software from that package. Seismosoft. Yes, I got the name of the software or the package. The company is called Seismosoft. They have Seismosignals, they have spectral matching software, they have many different software. So this is just one software from Seismosoft. This one is called Seismosignal. So we have here acceleration time history for the same motion, acceleration time history, velocity time history, and displacement time history. We are here in the time series tab. If we go to yes, if we go to the ground motion parameters, you will see here and also on the plot areas intensity as a percentage. You see, this is exactly as we calculated in the spreadsheet. And you can also see this column here, 1, 2, 3. The fourth column is the areas intensity in percentage unit. So that's it. If you go down until you find areas intensity equal to 5%, let's see, 5%. So we need areas intensity at 5. This is approximately 5. What time that correspond to 5% of areas intensity? The time is 16.88. Let's compare this to our spreadsheet. See, 16.87, which is the same. 16.88, 16.87, very small difference. So this is the time that corresponds to ARIS intensity of 5%. The same way we can find the next value at 75% and then 95%. So this is three different ways to calculate or estimate the D575 and D595. Thank you so much for watching. I hope you enjoyed this video. Please don't forget to subscribe and like. Bye.